In this example, we're given an object that has a total charge of -3 coulombs. As mentioned previously, that's a monstrous amount of charge. You would definitely not want to touch that object. Realistically, we probably wouldn't get that much charge onto a single object if we're talking about, some kind of metal sphere in the classroom or something like that. There's probably simply just not enough room to put that many electrons on it. However, this wants to know how many excess electrons does this object possess. Now, that term excess electrons might throw you off. All we mean is in order for this object to have a negative charge, it must have more electrons than protons. And what we basically are asking here is how many more electrons than protons are on this object. So we're not asking how many electrons, the total number of electrons on the object. We're asking how many more electrons than protons does this object possess. So after you go through and you kind of say, okay, well, here's one electron, here's one proton, and their charges cancel out. Once you cancel out all those charges, then you're going to still have some electrons left over because this is a negatively charged object, and we want to know how many extra electrons on top of all the ones that are canceling out the protons, so to say, do I have that makes this object have a charge of -3. So in general, we want to remember the elementary charge, which is plus or minus 1.6 times 10 to the -19th coulombs. And the general equation is the number of electrons or protons that we have times the elementary charge gives me the total charge on the object. So now I can kind of list out what I'm given. I don't know the number of excess electrons or protons. That's what we're looking for. But I do know, as always, the elementary charge is, in this case, we'll use the negative 1.6 times 10 to the -19th since it has more electrons, and the total charge on the object is -3. So I can kind of plug all that in. We don't know what the number is, but we know that the elementary charge is going to be the negative version of the 1.6, and the total charge on this object is -3. So I have to be very careful with my algebra, but if I divide both sides by the elementary charge, I get -3 divided by -1.6 times 10 to the -19th, which I do have to put in parentheses so that I divide properly. And we should find that the excess number of electrons is 1.875 times 10 to the 18th extra electrons. So I have 1.875 billion more electrons than protons. I don't actually know how many electrons in total the object has. I know how many more electrons than protons it possesses, as evidenced by that boxed value at the bottom right of the screen.